had some adjustments to our schedule due to our snow days in Texas. Crazy. So I'm out all this week. Okay. We were supposed to cover these two sets of notes last week when I was in person, but the weather pushed us back. So you're going to be looking at 7.5, 7.6, and 7.7 video notes as videos. Okay, so this is the first video. I'm going to go over 7.5 notes today, and then you'll need to come back and watch 7.6 and 7.7 the next days, and there will be practice assigned for each of these as well. So make sure you're doing the practice assignments after the lessons. Miss McPherson, our sub all week, will pass those practice and you'll get the outlines from her for the notes and all that good stuff. And then you'll have a review day. Our test was supposed to be here this week, but it's getting pushed back as well. So we'll test then that Monday, February 3rd, and that's when your review will be due. So you'll have a day to work on the review in class on Thursday, and then we'll continue working on our Texas College Bridge. You should have moved into part 2 of Texas College Bridge. If you're still working in part 1 this week, you are behind because part 1 deadline was on the 24th. If you haven't finished it, obviously you have to. You have to get to 90 on part 1 before it'll let you move on to part 2. Okay, but that's what that day is built in for, is to work on Texas College Bridge. If you feel like you're all caught up in Texas College Bridge and you need to finish some of the practice assignments from this week or finish the review, that's fine too. Just don't forget to work on that Texas College Bridge outside of class if you feel like you need extra time. Okay, so here, looking at 7.5. So, up to now in Unit 7, we've been talking about quadratic functions. We learned the basics of the graph, what the parent function looks like. It makes the parabola shape, and some of the different terminology, like the vertex and the axis of symmetry. And then we looked at quadratic formula, and we've practiced solving for x, which, remember, x is the x-intercepts. Okay, when we find solutions, we're finding x-intercepts. And up to now, we've had solutions. I'm actually going to pull up our completed notes and show you the last thing we talked about was here. We said when you calculate the discriminant is the part under the square root, under the radical. Okay, that discriminant tells you whether there will be one real solution, if that comes out to a 0. Okay, 2 real solutions, if that comes out to a positive number, or 2 imaginary or complex solutions. That's if the discriminant comes out to be negative. Up to this point, we've only done practice with 1 real or 2 real. Okay, it's either been 0 or positive. Okay, now what we're going to look at today is what happens if that comes out negative and we get these 2 complex imaginary solutions. When it was a real solution, 1 or 2, we could see the solution in the graph of the parabola. We could go to Desmos and graph it and see where does it cross the x-axis. With our complex or imaginary solutions, we're not going to be able to do that. We actually have to be able to use quadratic formula because we're not going to see it on the graph because it's imaginary. So we need to first understand what this new letter you're going to see is, and it's called I. So I is simply the square root of -1. Okay, I is the square root of -1. Now, when you square it, if you square square root, those negate each other. So if you square I, then it's just what was underneath, which is -1. Okay, so if we end up with a negative under our radical, we're going to rewrite it as an I. We're going to pull that negative out and write it as an I. So if there's a negative inside the radical, there will be an I in your simplified answer. Okay. Now it says use prime factorization to simplify the radicals. That means we're just going to leave them as radicals. And we're not going to get them as decimals. So here, we're going to start just practicing that simplifying, okay, before we jump into actual quadratics. Okay, they'll get more complex over here on the back, and then in 7.6, we'll solve some quadratics that will end up with a negative. But first, we just need to refresh on what I is and how to simplify these radicals. So the first thing I'm going to do in number 1 is I'm going to break this down. And some of you are not going to have to write this step, but I want you to see that -1 times positive 128, that's where that's factors of -128. And so that you can see the square root of -1, that's where I is going to come from. So you can pull an I out in front and then just have the square root of the positive 128. Now, when I say some of you won't need to write that middle line there, that's because you'll just say, oh, there's a negative. Let me pull out that I. It's going to become an I outside, and then just positive 128 is left inside. Okay, and that's fine, but I just want to have it in the notes so you can see why it works out that way. And it's because -1 times positive 128, those are factors of that. So we break it down so we can get I. So now we don't have a negative under the radical anymore. So now we're going to do prime factorization, which is our factor tree. Okay, so we need to come up with factors of 128. So what could multiply to 128? And if you struggle with your factors, you can use Desmos to help you come up with a list of factors. So whatever number you want factors of, 128 in this example, put it divided by X. So 128 divided by X. And then you're going to come to the gear and make a table out of that. And now this table will be factors, these two numbers in the columns multiply to give you 128. So it's only going to show you up through, so 1 times 128, 2 times 64, and then you can keep typing 3, 4, 5, etc. And that is, we're only looking for the ones that are integers though. So like 3 had a decimal with it, so that means 3 is not a factor because it doesn't divide out evenly. So we're only looking for the ones that are not decimals. So I could use any of these. I could obviously not 1 and 128. That doesn't get me anywhere new. But I could do 2 and 64 or 4 and 32. So I'll just pick 2 and 64. Okay, now, so these are the first 2 branches of my factor tree. Now, 2 is a prime number, meaning there's no more factors of it other than 1 in itself. So I can't go any further with 2. But with 64, I can keep going. That's 2 times 32. And if you don't know factors in your head, again, go to Desmos and make yourself a little table and find some factors. 2 is prime, but I can keep going with 32. That's 2 times 16. Again, I can keep going with 16 and with 8 and then with 4. So this is, if you do this with all, just keep dividing out a 2, it's kind of a long factor tree. But what we're doing, what this means, you don't have to write this every time, but just so you can see what this means, you've got the I in front still. This means that 1, 2, 6, 7, there's 7 2s at the ends of these branches. So this means 1, 2, 3, 4, 6. That's the same thing as 128. 2 times itself 7 times. And you could confirm that. Again, you can go to Desmos and confirm these things. So you can do 2, 3, 4, 5, 6, 7. And you can see that's 128. So you can say, okay, yeah, that looks good. I've done that right. Okay. And now I've gotten these to all prime numbers, and I'm looking for pairs because this is a square root. Okay, a square root. Square means twice. So I'm looking for pairs. So there's one pair, there's a second pair, and there's a third pair. And again, you don't have to write it like this. You can find these pairs in this factor tree as well. You can say there's one pair, there's a second pair, there's a third pair. Now, either way, whether you're looking at it written out like this or you're looking at it in the tree, there's a single 2 left, no matter which way you look at it, that doesn't have a partner. It's not a pair, it's a single. So what happens is when we do prime factorization, anything that had a pair gets to come outside the radical. So that's 1, 2, 3 pairs. So 3 2's get to come out because there's 3 pairs. Now that I is still out here, so I'm going to have that I. Now this 2 did not have a partner, so he's stuck underneath. Now I can simplify out here and go ahead and multiply. 2 times 2 times 2 is 8. So I can write this as 8i square root of 2. And I can't do anything further. You may see it written as 8 square root of 2 and then the I at the end. Okay, that's correct as well. But some people get mixed up when they write their I at the end. It is not under that radical. Do not extend this square root over the I. The I is outside. So sometimes it's easier for people to make sure that it's outside if they write it in front. So both of those are technically correct. You can write it either one of those ways, but that is the prime factorization. And then you can check 8 square root of 2. Let me double check that that's still the same as 128. So 8 square root of 2. Uh-oh. Did not. Oh, we want to make sure it's the same thing as square root of 128. Excuse me. So I got to type in the square root of 128. And those are the same. So 8 square root of 2 and square root of 128. They are the same number. We have just simplified, okay, using prime factorization, but you can see that it comes out equivalent. Okay, so that's what we're doing on these. So I'm going to start moving a little faster to go through these. So there's no negative here, so no I needed, but I'm just going to do my factor tree. So 108 could be 2 and 54. Could be 2 and 27. 27 doesn't divide by 2, but it could be 3 and 9. And 9 could be 3 times 3. So I'm looking for pairs. There's a pair of 3's, so a 3 gets to come out. There's a pair of 2's, so a 2 gets to come out. This 3 does not have a partner. He has to stay inside. Okay, and it's only the ends of the branches I'm looking at. So a pair of 2's, a pair of 3's, and then a single 3. And then I just simplify that 3 times 2 is 6. So 6 root 3. And I can confirm this at square root of 108 and 6 root 3. I want to make sure they're the same. So the square root of 108 and 2 root 3. Or did I write that backwards? 6 root 3, sorry. There it is. Square root of 108, 6 root 3, same number, so I can confirm that I simplified that correctly. Okay, now here, I've got a negative, so it's going to come out and become an I. I'm going to have an I on the outside. Now I'm going to do my factor tree for 72. 72 could be 8 times 9. Then 8 could break down to 4 times 2. And 4 breaks down to 2 times 2. and 9 breaks down to 3 times 3. Now, all of those are prime. So I've got a pair of 3s, a pair of 2s, and then this 2 is solo. Okay, so from this factor tree, I'm going to have a 2 and a 3 that get to come out, and a 2 that has to stay underneath. And then I'm going to have this that was already out here, doesn't go away. There's still a -4 out there, and the I that I brought out. So I've got all of this out front that I need to simplify. So -4 times 2 is -8 times 3 is -24. So I've got -24, then I've got the I, and then I've got √2. Or again, I could write that as -24 √2 and then the I afterward. Okay, so that I can be in front or behind. That's kind of your preference. Now, again, you can't check these in Desmos with the negative underneath, but you can think about just the actual number. And so, oops. Don't the other screen. Here we go. So if I think about just the number itself was the square 4. Well, let's ignore the negatives for now. Let's just think about the numbers. 4 square root of 72. So and then when we simplified, we got it ignoring the negatives and the I, 24 square root of 2. So our numbers come out the same. Okay, so we just have to pay attention to those negatives. Be careful with those. Okay, but we did the number simplifying correct. All right, let's move on to this next one. So there's no negative under the radical, so I don't have to worry about that. So I'm going to do my factor tree. That's going to be 2 and let's see, 56. You can factor that to, you can do any factors that work, but sometimes it's easier when it's even just to keep dividing out of 2 for some people. So it's 2 and 28. That's 2 and 14. Just 2 and 7, and 7 is prime. 7 doesn't break down anymore. So I'm looking again for pairs. There's one pair of 2s. There's another pair of 2s. So 2 pairs, so 2 2s come out, and then the 7 has to stay underneath because he doesn't have a partner to come out with and play. And then there's the -2 that was already there. Don't forget, that was already out here. Now I can simplify out here. 2 times 2 times 2 is 8. That's going to be -8 square root of 7. Okay, let's get a little more complex. All right, so here I can simplify my fraction first. It's going to make this a little easier. So to do this, both numbers here, you see this makes like a little triangle because this is separated here by a plus or a minus sign. The number in front and the number here, both, if they can both be reduced by this denominator, we can do that. Because technically I could write this separately. I could say that 18 is divided by 3, and then we have the minus, and then the 6 root -145 is divided by 3. So technically I could have both of those separated, and I can divide them. Again, some of you won't need to write that out. Okay, but the 18 divided by 3 is 6, and the 6 divided by 3 is 2, and the square root of -45 doesn't change. So I've gotten rid of my denominator, which is good, but now I still need to do my factor tree. So that could be 9 times 5, which breaks down to 3 times 3. And I can see there's a pair. So a 3 gets to come out. This 5 has to stay underneath. And then the negative comes out as an I. So there's an I out here. And that -2 is already out there. And then that 6 is it's separate in front. So these are being multiplied. That 6 is not being multiplied. There's this minus sign in between. So when I simplify this, the 6 will still be there, at least 6 minus, and then the 2 times 3 is 6i. And then you have the square root of 5. All right, over here, we can do the same thing, make that little triangle, and you can see both the 15 and the 5 up here in top will divide by 5. So this can come down. 15 divided by 5 is 3. 5 divided by 5 is 1. I don't even have to write a 1. A 1 is understood in front. So now I'm ready to do my factor tree. The I gonna come out because of that negative. 36. 36, you can do a factor tree, but technically you don't have to. It's a perfect square. It's 6 times 6. So even though 6 isn't prime, I could stop there because I see a pair. Oh, a pair, and then there's nothing left. So a 6 comes out, there's nothing left underneath, and then you have the I that you pulled out, and that's subtracted from that 3. Now I wouldn't write it like this. We don't like to write the I in front of the number, so I would rewrite this as 3 minus 6i. All right, now these are simplifying complex numbers. So this is using your basic algebra skills. We have a set of parentheses being squared. Remember, squared means multiplying it by itself. So I'm going to show that. It's there twice. So if it's there twice, then I can either do box method or just double distribute or FOIL. So everything gets distributed. So the -5 gets distributed to both of these. So -5 times -5 is 25. -5 times -I is positive 5i. And then you also distribute the -I to both. So the -I times -5 is again positive 5i. And the -I times -I is positive I squared. Well, on the front, we said that I squared is -1. So I'm going to replace that with just a -1. And then I can simplify here in the middle. 5i plus 5i is 10i. And I've still got that plus 25. Now I can combine these like terms here because now this isn't an I anymore. It's just a -1. So those can come together. So 25 minus 1 is 24. And then I've got plus 10i. Okay, so let's do that over here. Simplify what we can. So let's distribute this negative. So we've got this -7 in front that didn't move, and then this becomes -7, and then a negative times a negative becomes plus 6i. Same thing here, distribute this negative, becomes minus 8i minus 2i squared. Now I'm going to go ahead and replace that I squared with a -1. So a -1. And then you've got a -2 in front of it being multiplied. I'll go ahead and simplify some like terms here. So the i's, 6i minus 8i would be -2i, and -7 would be -14. Now I'm going to go ahead and simplify. -2 times -1 is +2. And so now that can be combined with the other constant. So negative 14 plus 2 is negative 12. And then you've got the minus 2i. All right, last couple. So we're going to do our double distribution. So we're going to distribute the 2. So 2 times 8 is 16. And 2 times negative 7i would be negative 14i. And then we're going to distribute the positive 8i. So 8 times 8 is 64. And there's an I there still. And then 8 times negative 7 would be negative 56. And then that's an I times I, so that's I squared. So we're going to replace that I squared with negative 1. So negative 56 times negative 1, that's going to become positive 56. Okay, and then in the middle here, I can combine like terms. So I've got negative 14 and positive 64 i's. So that is positive 50i. And then we've got that positive 16 in the front. Now I can combine these like terms. So 56 and 16 is 72 plus 50i. Last but not least, this is multiplication. Okay, a number up against a parenthesis. So 3 times 4i would be 12i. Okay, again, this is up against a parenthesis. So this negative 6i needs to be multiplied by everything in the parentheses. So negative 6i times negative 6 would be positive 36i. And negative 6i times positive 4i would be negative 24i squared. So again, we have an I squared, which is negative 1. So I make that replacement. So this negative 24 is being multiplied by negative 1, so it changes to positive 24. And then I can combine, these are both I terms, so I can combine like terms. 36 and 12 is 48i. So you can leave it like this, but notice everything else we've written has been a number plus the I term. Okay, the way that we write these complex numbers are typically in the form A plus BI. So you have the number without the I, and then your plus or minus, and then the imaginary part. So you have your real part plus or minus your imaginary part. That's what a complex number's proper format is. So technically, I'm just going to rearrange this and say 24 plus 48i. So we have the real part and then the imaginary part in our complex number. All right, and that is simplifying complex numbers and simplifying those rational expressions here on the front. Okay, so you can go back and watch this as many times as you need to help you with your practice. Okay, and that is it for 7.5.